We talked about lights, it's now time to talk about shadows. As in the real world, in 3D graphics, shadows are used to simulate the heat of a light on an object, to cast a shadow on another object or on itself. As you can see here, there are many concepts and techniques that we can use to create shadows. It is a fascinating topic because it can impact a lot the kind of render you can achieve, but you might sometimes need to choose between performance and realistic rendering. This is the starter pack we will be using for this lesson. Thanks to React 3 Fiber, it's way easier to use shadows than just vanilla Three.js. We just need to add shadows on the canvas. But even if it's simpler, it's not magic. For now, we can't see any shadows yet. You need to define what objects are casting shadows with cast shadow and what objects are receiving shadows with the receive shadow prop. But you also have control over which light is creating shadows and which one isn't. So let's just add shadows on this light, which is white by default. By doing that, even if we have two lights, only one is creating a shadow there on the back left. Let's add cast shadow also to the red light here. And you can see that we have very different shadow colors. The one coming from the white line on the right here looks very red, while the one coming from the red light looks very white because of the impact of the other light. Let's add more item to our scene. We will use a mesh with a sphere. So sphere geometry with a size of 0.5 and a mesh standard material of white. We'll position the sphere at 1, 1, and 1. If we want to see its shadow, we need to use cast shadow. We can see the shadow on the plane here, but not on the cube. It's because we didn't enable receive shadow on the cube. The cube is here. Let's add receive shadow. We can now see the shadows from the sphere on the cube. But the quality of it is not very nice. It's okay, it depends how far you look at it, but it's not perfect. Why does it look that way? It's because Three.js under the hood use a technique named shadow mapping. The fact of generating a shadow map, a texture that will contain the depth of the scene from the light's point of view. By default, the resolution of that shadow map texture is 512 on 512. We can change it using the shadow dash map size and set the array of dimension. Let's use 2048 for each. It's an array with the width as the first parameter and the height as the second parameter. Oh, I think I didn't make it on the correct one. We should set it on the white light. It's the one triggering shadow on the cube. Now you can see on the cube it's not pixelated anymore. At least less than it was before. But be careful because the more you have objects, the bigger the texture are, the more it will consume resources. And based on the device or the number of objects, it can impact the performance of your app. But even this with that resolution, it looks not very natural, it's too sharp. So we can do the opposite, use a very small texture size. And by doing this, it will look blurry because it will stretch it and looks better. So if it's the kind of result you are looking for, it's a good strategy because it consumes less resources and have a better aspect. But let's remove that prop because there are other techniques to make soft shadows that we will see together later. Now to introduce you shadow camera, let me do something. We will duplicate all our meshes. We will wrap them into a group. But we will position them far away. For example, this group position X is equal to 10. So let's see what we have. We have this first group with the shadows. And here it's the same settings, but we don't have any shadows. But it's not based on the lights because the lights are directional lights. So wherever you are, it should appear. And as you can see, the colors of our object are exactly the same. So what is the reason to this? It is because to calculate the shadow map, Three.js is using a camera. And as we've seen in the camera lesson, it has different properties to display what it will render and what it will use. So for this one, positioned at the center of our scene, it is rendered into our directional light camera. But this one here is not, so it cannot generate shadows. We can change the directional light shadow camera with the props shadow camera dash and the camera property value. We can say far is equal to 50 then left is equal to -10, right is equal to 10, top to 10, and the bottom to -10. By doing that, we still have the shadows on the left one, but also on the right group, only for one light because the other one I didn't affect it. If you want to dive deeper, I recommend you to read the directional light shadow documentation. You will learn that it is using an orthographic camera to calculate those shadows. And with React Refiber, instead of doing this and assigning the props here, we can nest into our directional light directly an orthographic camera. But to tell Three.js that this orthographic camera is the shadow camera from the directional light, we need to add attach and say shadow camera. Then we can use the arguments, so the array of args like any other Three.js object, and use, like we did previously, -10, 10, 10, and -10. You can see on your project that it changed absolutely nothing on the rendering. It's working. But because now you declared the orthographic camera, you can have a reference and use helper to positionate that camera correctly to have the correct shadow. Okay, let's clean a bit our project. Let's remove that camera and let's remove the duplicate group here. Okay, so far this is what we have. The shadows are back to what they were before, and they look very sharp. Instead, we can use a very nice tool. It's a component from Dry. It's named Soft Shadows. You just have to add it inside your canvas, and it will automatically smoothen the shadows and looks pretty nice. Currently, our shadows are calculated at every frame, every time. Let's move the cube to see how it reacts. Let's use a Leva again, use controls. Let's say cube in air and set it to false by default. And we will get that variable here. Now let's find our cube, which is this one here. Let's change its position Y based on cube in air. So either it's in air, we will set it to 1. Otherwise, we set it to 0. Now let's try cube in air. We click on it and we can see the cube is in the air. The shadows here change, and also the shadows from the sphere on the cube is updated. It's not at the same place. But it can be expensive for your browser to always calculate shadows. And sometimes you don't need to because you have static objects that don't require to calculate it at every frame. So instead of calculating them in real time, you can use the bake shadows property that will bake the shadows. After it's calculated, it will freeze them. Now, if we try to move the cube, you can see that the shadow on the floor doesn't move. Okay, let's get rid of it. And let's also remove shadows. Now we don't have shadows anymore, but we will use a component from Dry library named contact shadows. And instead of using light sources to cast the shadows, it's using the shape of the object from the geometry. So now without re-enabling shadows, we will add the contact shadows component. This is what we have. It's like a plane floating in the air containing the shadow information. Let's set it position Y just over the floor, so -0.49. Let's change the opacity to 0.5 so it will look less harsh. Let's change the blur to 2 to soften it. We can also impact the color and change the scale. Now if you look at it, it's perfectly on the floor and it looks way smoother and better integrated. But the rendering is different from the one we had before with directional light shadows. With contact shadows, you also have the option to use the frame parameter, which is how long you want to calculate those shadows. So if you set frames to 1, it will bake them for 1 frame, and it will improve the performances. Let's talk more about baking. We have seen how to freeze our scene using the bake shadows component, but we can do a process which is called baking, which is calculating the light and shadows and save it into a texture. And when you are doing this process, because it's loaded at runtime, you can use more powerful engine that require more time. For example, on the left, we have real-time calculation, and on the right, it's using ray casting, but it's baked into a texture, so it doesn't impact the performances. but the result is way more realistic. It's a more advanced topic and you will require a blender to bake the texture, but I have a video on my YouTube channel, you can find the link in the lesson, and you will learn how to bake this scene. Let's see a last component to create shadows with React 3 Fiber. Its name is Accumulative Shadows. This is how I made the shadows here on the intro of the course. Maybe it won't be the same when you will watch the video, but here it's the actual one. So this component, in opposition to Contact Shadow, it really works with the lights, but it's like an hybrid approach of baking and rendering different lights. Because what we will usually do is use randomized light to have different lights showing up, calculating the shadows for a certain amount of time, and render this, but then it won't change. It's not done for real-time shadows. Let's remove our contact shadow here and use accumulative shadows. As I mentioned, it's working with the lights, so we need to enable shadows again. And inside our accumulative shadows, we need to define the light that will be impacting the shadows. For that, we will be using the randomized light from Dry, and they have many parameters to generate light that will move during certain amount of frames. We define the amount of light we want, let's say 4, the radius 9, the intensity, the ambient, let's say 0.25, and its position. Let's put the first one at 5, 5 and -10. Let's duplicate it and change slightly the parameter. So we just impact the ambient here and decrease the intensity. And let's say the position to -5, 5 and -9. Now we need to adjust the properties of our accumulative shadows. To not make it rendered all the time, we need to add the temporal one and say the number of frames we want to calculate. Let's choose 35. But of course, you can adjust the way it looks the best for you. We can impact its transparency with alpha test. Let's put it to 0.85. Its scale to define its dimension. Let's say 5. Its position. So 0 minus 0.499 and 0. And also the color of the shadow we want to make. Let's put a random one. I choose EFBD4E. And when we reload, we have that nice effect here with that brown color, and we can see the details of that shadows. It looks more realistic. The perfect combo is to use contact shadows over the dynamic object, like I did for the character here, and accumulative shadows for the static ones.